To start off, the Merriam-Webster dictionary states that a venturi is a short tube with a tapering constriction in the middle that causes an increase in the velocity of flow of a fluid and a corresponding decrease in fluid pressure, and that is used especially in measuring fluid flow or for creating a suction. The venturi design of the rails in the tunnel help create an airflow so the CO2 is swept up into the vents that line the bottom of the walls, so the CO2 doesn't settle on the road because of its density, effectively clearing out the tunnel and filling the greenhouse with CO2 to make the plants happier. This venturi uses the railings to make the airflow. Separate sections of railing are bent into a long hourglass shape to create a sort of vacuum. Imagine a fish tank full of water that needs to be emptied, and for some reason you don't have a pump. The easiest way to get that water out would be to submerge a length of hose in the water, block one end, and drape that end over the side of the tank, releasing the blocked end as you do. This creates a vacuum that sucks all of the water out of the tank, so even though the water has to travel up through the pipe, it empties the tank. This is the same idea as this larger venturi. The cars push air into the tunnel as they pass by, and coupled with the wide mouth and narrow middle of the venturi, the air gets sucked through that narrow space out to the wide end of the structure, creating an almost ceaseless airflow that streams right into the vents for the greenhouse. What doesn't go into the vent is pushed further down the tunnel through another set of venturi-shaped railings. Even with the venturi system in place, there would have to be gaps between greenhouses every half mile to 1 mile to allow clean air into the tunnels for fresh supply. The venturi design would create a draft so a lot of emissions would flow into the greenhouses, effectively cutting down on the amount of CO2 being distributed into the atmosphere, especially if these greenhouses became commonplace all over high. The model for the greenhouse is created by 6-inch stainless steel pipes and separated lengthwise by 10 feet for structural support. The inner and outer domes would both have 4-foot walls of cement to keep the metal off the ground. The outer dome of glass stops 10 feet from the wall, while the pipes continue on to the outside wall. The empty space between the concrete wall and the inner wall is for a water system that will be set into the ground with 2 solar-heated sheets of metal at an angle to pour rainwater and snowmelt into pipes that lead to a larger water tank inside the greenhouse for the purpose of a watering system with mainly naturally gained water. 2.5 feet of piping in glass will make a blocking barrier above the outer edge of the outer wall to create a block for 2 purposes. The wall would then be 6.5 feet high, keeping most people from climbing the dome, and more snow would be able to pile up before it melted into the pipes below. The roof of the greenhouse portion of the structure will be made out of a special type of panel, since unfortunately recycled plastics are less than ideal for greenhouse roofing. Instead, it will be made out of polycarbonate panels, while above the highway would be paneled with several separate pieces of toughened safety glass. For more structural support and safety, between the first and second dome, the glass panels will be supported with crossed pipes to keep them from collapsing from pressure coming from rain and snow. There are 2 floors of greenhouse with about 9-foot ceilings on either side of the highway. The upper floor of the greenhouse will be filled with plants that need maximum sunlight. Rows of shelves with the plants that need the most sunlight will sit closest to the shorter wall, since that space would have the highest concentration of light, while the higher side would have more distributed sunlight. The bottom floor will have the shaded plants and the plants that grow best underground, like potatoes. On the section of roof right before the empty space made for the snowmelt and rainwater, there will be solar panels to collect power to heat different rooms in the greenhouse. Before the solar panels on the roof will be a small section of polycarbonate panels used for the greenhouse roof, but there will also be 10-foot by 4-foot windows with easy catches that can pop up in case of an emergency. Above those windows are more polycarbonate panels, and beyond that is the toughened glass that will give people in the tunnels a good view of the sky despite them being in a tunnel. The ends of the greenhouses will also be cut off by panels of polycarbonate to prevent anyone throwing things down at cars. If these greenhouses become commonplace, there would be minimal snow or rain on the roads, and the insides of these tunnels would be lit up at night, so the roads would be a safer place as well. These greenhouses will need to be staffed, which will create hundreds of jobs for just a mile of greenhouse. The CO2 intake will help significantly with the climate problem we're currently facing, especially if other, more basic measures are implemented. The plants grown in these greenhouses will be organic and going to feeding homeless people, while the lower floors could act as shelters for the homeless in extreme weather and cold. Since the plants wouldn't be sold, only given out to the needy, there would be no competition with the local farms. Not only would this project cut down on emissions and help the needy, everything used inside of the greenhouses would be made from recycled materials, including the shelves for plants, the pots, seating and tables, storage bins, etc. Anything that can be made out of recycled plastic will.